Imagine our planet suddenly vulnerable. A vibrant world teeming with life floating in the vast, silent expanse of space. But what if the invisible force protecting us from deadly cosmic radiation was fading? What if our shield was beginning to fail? For billions of years, Earth has been wrapped in a protective embrace, an invisible, dynamic force field generated deep within its core. This is our planet's magnetic field. It acts as a cosmic sentinel, deflecting a constant barrage of charged particles from the sun, known as the solar wind, and shielding us from high-energy cosmic rays originating from distant supernovas. Without this shield, the solar wind would strip away our atmosphere and life as we know it would be impossible. It's the silent guardian that makes our world a habitable oasis. We see its power painted across the polar skies in the ethereal dance of the auroras, a beautiful reminder of the celestial battle being waged above our heads. But this shield is not uniform, nor is it permanent. Over the South Atlantic Ocean, stretching from Africa to South America, a strange anomaly is growing. Here, the magnetic field is weakening faster than anywhere else on the globe. Scientists call it the South Atlantic Anomaly. For satellites and spacecraft passing through this region, it's a danger zone. The International Space Station, orbiting just 400 kilometers above us, must power down non-essential equipment to protect its delicate electronics from damaging radiation. Astronauts on board report seeing flashes of light, even with their eyes closed, a direct result of cosmic rays striking their retinas. This growing dent in our magnetic armor is a clear sign that something profound is happening deep within our planet. The cause lies thousands of kilometers beneath our feet in the turbulent, fiery heart of our world. The Earth's outer core is a vast ocean of molten iron and nickel, churning and swirling at temperatures hotter than the surface of the sun. This restless motion of liquid metal, driven by the planet's rotation and heat from the solid inner core, creates powerful electrical currents. This process, known as the geomagnetic dynamo, is what generates our planetary magnetic field. But this dynamo is not a steady engine. It's chaotic and ever-changing, causing the magnetic field to fluctuate in strength and direction over geological time. The South Atlantic Anomaly is a surface expression of this deep inner turmoil. So, what are the consequences if this weakening continues? A weaker shield means greater vulnerability. Imagine a massive solar storm, a coronal mass ejection, hurling billions of tons of magnetized plasma toward Earth. A strong magnetic field would deflect the worst of it. But a weakened field could allow these energetic particles to penetrate deeper into our atmosphere. The immediate effects would be felt in our technologically dependent society. Satellites responsible for GPS, communications, and weather forecasting could be fried. Power grids could overload, plunging entire continents into darkness. Air travel would be disrupted as navigation and communication systems fail. The auroras, normally confined to the poles, might be seen at much lower latitudes, a beautiful but ominous spectacle. Our interconnected world is surprisingly fragile, and its stability is tied directly to the invisible shield above. Scientists believe this weakening might not be a temporary dip, but the prelude to something far more dramatic, a full geomagnetic reversal. This is a process where the magnetic north and south poles completely flip. It's not science fiction. Geological records locked in ancient lava flows show this happened hundreds of times throughout Earth's history, roughly every few 100,000 years. The last full reversal occurred about 780,000 years ago. During this transition, which can take thousands of years, the magnetic field doesn't just vanish. Instead, it becomes much weaker and more complex, with multiple north and south poles emerging all over the planet. Using data from missions like the European Space Agency's swarm satellites, scientists are meticulously mapping these changes, trying to understand the timeline and what a future reversal might look like. While the prospect of a planetary-scale event sounds alarming, there's no need for panic. A magnetic reversal is a slow, natural process. It won't happen overnight. Our shield may be fading in some areas, but it is not failing entirely. The Earth's atmosphere itself provides a substantial secondary layer of protection from radiation, even with a weaker magnetic field. The greatest challenge lies not in surviving the reversal itself, but in adapting our technology to withstand it. By studying this planetary-scale phenomena, we are not just looking at a potential threat. We are gaining a deeper understanding of the complex living systems that govern our world. It's a humbling reminder that we are passengers on a dynamic planet and that its future is intrinsically linked to our own. Our fading shield is not an omen of doom, but a call to listen, to learn, and to appreciate the fragile, powerful forces that make our existence possible. Thank you for joining us on this journey to the heart of our planet. If you found this exploration fascinating, don't forget to like, share, and subscribe for more deep dives into the wonders of our universe. Stay curious.